am Hariharan, participating in the research. In this video, I'm going to explain my project with EP. This is ESP32 I am using in my project. I am using Wokwi to test my code and implementation. For hardware implementation using Thonny software, 2 push button and 1 LED for blinking light. ESP32 using 1 push button SW, 1 connected to GPIO 12 and SW, 2 connected to GPIO 14 and LED cathode connected to ground and anode connected to GPIO. Overall connections for all experiment. Experiment 1 simple code and output is SW1. Pressed counter increases by 1 print updated value in the shell. SW. 2 pressed counter decreases by 1 print updated value in the shell. Experiment 2 little bit changes in code. Define subfunctions to check button states using def main loop. If SW1 is pressed, call function to stop the program and print end program. If SW2 is pressed, call function to blink the LED, 3 seconds on, 1.5 seconds off, 7 times, while loop ensures continuous checking of button states. Setup configure SW1 and SW2 as inputs. Configure LED as output subfunction use, a def function with dot value to read the button, state main loop while true. Continuously check if SW1 is pressed, value, HACOS 0, turn LED on. If SW1 is released, turn LED off. If SW2 is pressed, print end program. At startup, the program begins by making the LED blink slowly, turning on for 1.5 seconds and off for 1.5 seconds continuously. This serves as the default state. The program constantly checks the status of 2 input buttons, SW1 and SW2, using a subfunction that reads their value states inside a while loop. If both SW1 and SW2 are pressed at the same time, the program immediately stops the blinking and prints all pressed on the shell. If only SW, same output compared to previous experiment. Startup LED blinks slowly on 1.5 seconds, off 1. Different I changed program and different functions. Short press, less than 1 second. LED blinks once, print short press. Long press, greater than or equal to 1 second. LED blinks 5 times, print long press. Uses time module to measure press duration, and a while loop to wait for button release output. Short press show. Short press if press more than long it's show. Long press. This program tracks a counter using SW1 and SW1 press, increases the counter by 1, and prints. Count. XSW2 long press, greater than 2 seconds. Resets the counter to 0, prints, counter reset. LED blinks rapidly 3 times as a visual reset cue. LED behavior, if counter is even, LED stays. On if counter is odd, LED stays off. The program uses a counter variable, checks SW2 press time using the time module, and uses dot value and while loop for real-time input detection. Output if press SW1 count. 1 count if press SW2 counter. Reset. Count. 1.